So for the last lesson of the unit, we're going to kind of switch gears a little bit, and what we're going to be talking about today is two-way frequency tables and data that you can pull from them. It's similar to our very first lesson where we made frequency charts, but two-way meaning we're going to be looking at two different sets of data on the same table. But it's slightly different than everything else we've done because the statistics I'm going to ask you to pull out have more to do with probability, which I know you guys did a little bit of that last year. You will be doing more of it in the years to come, but we're going to kind of start it this year. So it has a little bit to do with probability, which is why it's kind of at the end. So it's related, but a little bit different than anything we've done so far. So a two-way frequency table, there are actually like three different kinds of two-way frequency tables that we're going to talk about. So I just am going to give you the general definition, and we won't have an example for that one because there's just a lot of different kinds. So we didn't have to do multiple definitions. I'm just going to do a general definition for you. So it's a table in which the frequency meaning number of times it shows up, in which frequencies correspond to two variables. Hence the two-way frequency table. So it would be kind of like if I were to take all the heights of that won't work. It has a lot to do with non-numeric data, so data where I'm asking you your favorite color. So I might ask you what's your favorite color between blue and pink, and we would look at boys versus girls. So we could look at how many boys prefer blue to pink, and we could look at how many girls prefer blue to pink, and put it all on the same table, and that's a two-way frequency table. So it's looking at non-numeric data, and we're categorizing the data in two different ways. Okay? Okay, so for our actual notes, I give you, there's a lot of vocabulary in this section, but I tried to simplify it as much as possible. So these boxes that have the little bubbles and the arrows going to different things is going to help you kind of remember what it is we're talking about. So we're first going to talk about the generic two-way frequency table. And remember when we did 6.1, we talked about frequency being the number of times something shows up. So in this example, and this is going to be the same example for all of these boxes that give you the different parts. We surveyed boys and girls and asked them if they own a bicycle or do not own a bicycle. So this just kind of takes that data and separates it into those categories. So we could look at the number of boys that own a bicycle and the number of boys that do not own a bicycle. So if 16 boys own a bicycle and 4 boys do not, how many boys total were surveyed? 20 of them. Okay? And we could do the same thing for girls. 18 girls own a bicycle and 12 do not. So how many girls were surveyed? 30. How many total kids were surveyed? 50. So anything in the totals column is called marginal frequency. There are other totals columns that we could look at going downwards. If 16 boys own a bike and 18 girls own a bike, how many kids own a bike? 34. That is also marginal frequency. So, and then you could do the same thing for do not own a bike. Do you have an idea of why we call it marginal frequency? The totals. Okay, so the totals show up. So our marginal frequency are all of the ones on the total columns, which are the margins of the table. So you guys know how like line paper, that red line gives you a margin? Marginal frequency are the numbers that are in the margins. The only one that is an exception to that is this 50, which is your grand total. Okay? Anything inside of the table. So any of the frequencies inside of the table, 16, 4, 18, 12, that is called joint frequency. You guys know how like your forearm and your, what is that? So this would be your forearm and this would be your bicep, I guess, or your upper arm. They meet here at your elbow, and your elbow is considered a what? A joint. So it's where two different parts meet, right? You also have joints in your fingers where the different bones meet, or joints in your knee. So the joints are where two different sections, like on your body, meet. So it's the same thing in the table. The joint frequency of girls that do not own a bike means I'm looking in the row for girls and then the column for do not own a bike. So the joint frequency of girls that do not own a bike is what? 12. What is the joint frequency of boys that do own a bike? 16. Make sense? So marginal frequency falls in the margins. Joint frequency falls in where two of the criteria meet. And this is just the frequency, so I just want to know how many. Okay, so you're just listing the number. All right? So what I want you guys to do, using that information that I just gave you, so I scroll down just a little so you can see problem 1. On problem 1, I give you some information in, just some information, not all of it. I want you to fill out the table using the given information and then do some problem solving to fill out the rest of them and then answer these questions underneath, okay? So the information that you are given, I want you to fill into the table and then fill in all the missing information, which you should have enough, and then answer the questions. Go. Okay, so here's the information that's given to you. You guys are going to help me fill out the table. On Saturday, 201 tickets were sold for 2 movies. Where can I put 201? In your grand total. Okay. Movie A and movie B. Of the 103 tickets sold for movie A, so where would I put that?
Margin frequency on the movie A.
Total for movie A. 78 of those were sold to men. So I'm going to put 78 here. Of the 98 tickets sold for movie B, 98 in movie B, 86 were sold to women. So 86 is going to go here. And then I want you to finish the table. So let's look at movie A. If there were 103 tickets sold and 78 of those were to men, how many women saw movie A? 25. Good. Okay. And then how many men saw movie B? 12, right? Okay. And then we're going to do, I need to pick a different color. Here, let me change this. So this was 103. So we'll do marginal frequencies in the same color. So 103 and 98. How many men total went to the movies? 90. And how many women total went to the movies? 100 and what? 11. Does 90 plus 111 add up to 201? Yes. And does 103 plus 98 add up to 201? Yes. Okay, so we know that we're okay. So then my question is, what is the joint frequency of women who saw movie B? So that means I'm looking inside the table of the women who saw movie B. How many women saw movie B? 86. What is the marginal frequency of people who saw movie A? How many people total saw movie A? 103. And then the other question is, what is the marginal frequency of men who went to the movies? How many men went to the movies? 90. So what I'm really testing is so that you guys understand that marginal frequency can be from either margin, right? So it can be the total men, the total women, total movie A, or total movie B. Okay? Seem easy? Let's make it more complicated, shall we? Okay. So, oops. Okay, so we also have what's called a two-way relative frequency table. So what I want you guys to do is underline that word relative. That means when we are doing a two-way relative frequency table or are looking for relative frequency, I'm looking for the frequency of whatever I'm asking relative to the total, which means I'm looking for a fraction. So I'm looking at how many men saw movie A out of all of the people that saw movie A. So you're going to write it as a fraction. So this is the same bicycle status question that we did just a few minutes ago, but this time I'm looking for relative frequencies. So the marginal relative frequency is still in the margins. So you're still talking about these boxes. Oops, these boxes. The only difference is that I put it all out of 50. Why would my denominators be 50?
Because the grand total is...
Exactly. The grand total is 50. So when I am asking for marginal relative frequency of people that own a bicycle, I take the 34 total people that own a bike, put it out of 50, and my marginal relative frequency is 0.68. Okay, could we change that to a percentage if I asked you to?
68%.
Yep. What this is saying is that 68% of people who we surveyed own a bike. Okay? This is actually what, have your parents ever received phone calls asking them to take a survey? Or like on Starbucks, if you guys go to Starbucks and sometimes they'll email you a survey that they want you to take. People that get the data from your survey, this is what they do to it. So they look at 75% of our customers said that they were satisfied with their purchase or whatever. So this is like what people actually do. So we're looking at marginal relative frequency. You get the information from the same place as marginal frequency. The difference is that we're putting it over a fraction. So if it says relative, that means you are looking for a decimal for your answer. Okay? I don't want you to change it to percents. Just leave them as a decimal. So then joint relative frequency means that we're looking at the joint frequencies relative to the total. So we look at all the joint frequencies, put them out of 50. So if I am looking for boys who do not own a bicycle and I want the joint relative frequency, I'm looking at this box and I take the 4 boys that do not own a bike, put it out of 50, and I get 0.08. So what percentage of boys do not own a bicycle? 8%. So 8% of the people we surveyed are boys that do not own a bicycle. Make sense? But you'll leave it as a decimal. I won't even ask you to put it into a percentage. Okay? So what you are going to do for problem 2 on the next page is you're going to make a joint relative or a two-way relative frequency table. So you're going to take all the data from number 1 and you're going to put them all out of what? 201. And you're going to find the joint relative frequency or the marginal relative frequency of all of those, and then answer the questions. Okay, so for your relative frequency table, I do want you to show your decimals, but I'm not going to have a lot of room, so I'm going to just do a little bit. So for men who saw movie A, that would be 78 out of 201, which would give me 0.39. Okay. What about women who saw movie A? What'd you guys get? 0.12? Okay. And then the total people that saw movie A? 0.51. So just over half of our surveyed people saw movie A. What about movie B? What would be the joint relative frequency of men who saw movie B? 0.06. Women would be 0.43. And the total should be 0.49, right? Because this one should come out to a 201 over 201, which is 1. What about men total? So what's the marginal relative frequency of men who went to the movies? 0.45. And then the marginal relative frequency of women? 0.55, which should also add up to 1, right? Okay. So then, you guys have actually already answered some of the questions, so let's just go through these really quick. What is the joint relative frequency of women who saw movie A? 0.12. What's the joint relative frequency of men who saw movie B? 0.06. And then the marginal relative frequency of people who saw movie A would be 0.51. Not too bad. The one thing that I do want you guys to be aware of is, especially on like a test or a quiz, I'm not going to ask you to do a two-way frequency table and then take all that information and make a relative frequency table, because that's a lot of work. So do you think you could go from this table, so this one, and be able to give me the relative frequencies as well? Okay. That's mostly what you're going to be asked to do. Really what I want you to make sure you recognize is that if I just ask for frequency, joint frequency or marginal frequency, it's just the numbers. Okay? If I ask for joint relative or marginal relative, that's when you give me the decimals. And this is how you would show your work on those. You would just write me the fraction to show your work, but I would not require that you give me the entire table for all of them. Does that make sense? Okay. Because that's just a lot of busy work, I think. I think you can still show me that you understand by just giving me whatever specifically I'm asking for. You just have to make sure that you're reading the question. Okay? Is it asking for the frequency or is it asking for the relative frequency? Okay? So you ready for the very last one? Because of course I can't make it that simple. So we also have what is called conditional relative frequency. So it has the word relative frequency in it, which kind of gives me a clue that it's going to be a decimal. So I'm going to be looking at fractions. But the word conditional means that what I'm looking for depends on something else. So conditional relative frequency means that I'm not looking at the frequency relative to the total. It means I'm looking at a frequency relative to whatever my condition is. And I'll show you what I mean in a second. So conditional relative frequency is the joint frequency divided by that frequency's row total or column total. Okay. So you're looking for the joint frequency divided by the row total or the column total, depending on what condition I give you. Okay. So it is your relative frequency, but it's relative to whatever the condition is. So we're going to actually do this problem together so that we can kind of understand what's going on. The citizens of Parkdale are preparing to vote on a bond issue to fund an expansion of the public library. The table records data about support for the bond issue. So there are two categories to categorize people in. Either they support the issue or they oppose the issue, meaning they don't agree. But then we took all of the people that we surveyed and we split them up by their age. So we split people into the 18 to 25 age group, 26 to 64, and then greater than or equal to 65. So 65 years or older. So it did not give us the totals yet. So let's fill out the totals column. The chart gave us was the joint frequencies, right? So we need to fill in the marginal frequencies. So how many people total supported the issue? 79 of 18 to 25-year-olds, 57 of 26 to 64-year-olds, and 33 of 65 or older. How many people total supported the issue? Did anybody get it yet? 169. Okay. So add up for me how many total people opposed the issue. So what is the marginal frequency of people who opposed the issue? What did you get? 132? Agree? Okay, so how many people total were surveyed? What was my grand total? 301? Okay. What is the marginal frequency of 18 to 25-year-olds? 98. What is the marginal frequency of 26 to 64-year-olds? 102. And what's the marginal frequency of senior citizens? 101. Okay. So then I'm going to ask you these next three questions are asking for conditional relative frequency. So I want to make sure that we're reading very carefully what this is asking for. So let's read it and let's see if you guys can see what the difference is between what we've done so far. Part A, what is the conditional relative frequency? So I want you guys to underline it just so you know what we're looking for. That a person surveyed supports the bond issue. And then here's the important part. Given that the person is between 18 and 25. So I'll read that to you guys again. What is the conditional relative frequency that a person supports the bond issue given that the person is between 18 and 25? What does that given mean? Any ideas? Tell your neighbor what you think it means. So I think you guys are on the right track. This given that the person is between 18 and 25 means I am telling you for sure we're only looking at the 18 to 25-year-olds. So I'm only looking at these 98 people that were surveyed that are between 18 and 25. There is no other way that we're looking at the other age groups. So of those 98 18 to 25-year-olds, what is the conditional relative frequency that they support the issue? So it's asking, of the 18 to 25-year-olds, how many supported the issue? So of these 98 18 to 25-year-olds, so my denominator is going to be 98, not the grand total. Okay, that's what the conditional part means. So whatever the given is, given that their age is between 18 and 25, so I know I'm only looking at these 98 people, that's going to be my denominator. What is the relative frequency that they support the bond issue? So of those 98, how many support the bond issue? 79 of them. So our fraction is not going to be 79 out of 301. It's going to be 79 out of 98 because it's conditional. So I'm telling you in the problem that I'm only looking at 18 to 25-year-olds. Okay? When you actually do that, you should get 0.81. So the conditional relative frequency is 0.81. So what I want you to do is try B and C for me. Okay. Okay, guys. So the second one is conditional relative frequency, that a person surveyed, again, supports the bond issue given that the person is between 26 and 64. So I'm only looking at this column now. So what's going to be my denominator? Good, 102. And of those 102 people, how many support the bond issue?
57.
Good, 57. So that comes out to 0.56. Okay, and then the last one, conditional relative frequency, that a person surveyed supports the bond issue given the person is over 65. So what's going to be your denominator in that one? 101. And how many over 65-year-olds support the bond issue? 33, which comes out to... Oh, I didn't do it. What does it come out to? 0.33?
Yes.
Okay, 0.33. Okay, so what are you noticing? And this is going to kind of help you answer part D. What conclusions can you draw based on the conditional relative frequencies of A to C? So what are you noticing, Jonah?
As you get older, you care less, you support less.
Yes. So as you get older, according to our survey, as our surveyed people get older, less of them support the bond issue. So I want you to write that in a complete sentence in part D.